Welcome back, students. Now in this part I'll be telling you something about aluminium extraction. Aluminium is a very important element which is present in this boron family. In this part I'll be telling you how do we obtain aluminium, how do we purify them, okay, and how do we get the most purest form of aluminium. So here we go. So students, till now we have discussed the boron family. Now I'll discuss one important compound in the boron family which is very useful: aluminium extraction. How aluminium is getting extracted? Let's see. So it is a very reactive metal according to the electrochemical series, but it is unreactive. Why it is unreactive? Due to the formation of a oxide film, okay, of Al2O3 on its surface. So that makes it somewhat unreactive, and in nature it occurs like this way, either in bauxite or cryolite or feldspar or mica. In all these four forms, my aluminium exists as a mineral, you can say. Now, how do it get extracted? So this is a two-stage process. Stage 1 process involves the extraction of alumina, which is Al2O3 from the bauxite, and the second stage it involves the extraction of pure aluminium from Al2O3. So first we will extract Al2O3, and then from that Al2O3 we will extract our aluminium. That is the full stage process, and the process of extraction of aluminium from Al2O3 is done by actually electrolysis. Okay, in molten cryolite is the electrolyte we take, cryolite. So we'll see that the whole process of electrolysis. So first is a purification of bauxite. So bauxite, it contains SiO2 also, iron oxide also, and titanium oxide also as an impurities form. So it has to be digested with hot concentrated solution of NaOH. You see the temperature, 473 to 523 Kelvin. How high is that temperature? Even the pressure, 35 to 36 bar pressure. So what happens? Your aluminium oxide and silica, it dissolves to form sodium aluminate. Okay, sodium aluminate, and that sodium silicate respectively, which leaves behind my iron oxide and TiO2. So these two are getting filtered off. My iron oxide and my titanium oxide. So what remains is sodium aluminosilicate. Okay. So after this you can have your aluminum hydroxide with you, and this is filtered off and dried. Okay, and calcinated. What is calcination, guys? Calcination is nothing but heating anything in the absence of air. In the absence of oxygen. So it will yield you Al2O3. It will give you Al2O3, alumina, pure alumina. like this way. Then we will move on to the second stage, electrolysis of the pure alumina. This is also known as Hall-Héroult process. Okay, Hall process of extracting aluminium. So it is dissolved in molten cryolite, Na3AlF6 is the formula, and is electrolyzed. Okay, lined by carbon electrodes internally. So they act as cathode also, they act as anode also, and your dipping rods, they are fused in the electrolyte, they serve as anode. Both are actually carbon only, but one is your cathode, another is in the dip form of the electrolyte, so that is your anode. The cryolite, which is the electrolyte you have, okay, it contains it is the 80 to 85% content of that electrolyte. Then CaF2 also we take, and AlF3 also we take, also Al2O3 as an electrolyte. This is the cell, okay, electrolytic cell. You can see electrolytic cell for the purification of aluminium. Here you have anode, here we have cathode. This is your cathode lining, okay. This is your anode, which is dipped, which I was talking about. And you have your electrolyte here. and this is the outlet for aluminium. If you push it out, you will get your aluminium. So the reactions going on cathode are Al3 plus 3 electron give me Al, and in anode I will form my carbon dioxide or carbon monoxide. So I will get my aluminium extracted at the cathode here, okay, at the cathode. This is how my aluminium is getting extracted, which is a very useful metal, okay, in different applications, maybe in heavy aircrafts, or say in light your all plates, okay. So it has a variety of application. So students, in this part we learned about aluminium extraction. First of all, we saw that in which forms my aluminium exists as a ore or a mineral, and then how do we purify them, okay, how do we obtain first of all that ore, and then how do we purify them. We also get to know one method, that is your electrolysis method, and which is known as your Hall-Herold's process, okay, Hall-Herold's process. We also saw what cryolite technique was. Now in the next part, I'll be telling you about most abundant element that is also present in the P block only, and that element is your carbon family. So stay tuned with me for that.